Good morning. In this exercise, I'm going to do an example on integration suitable for years 17 and above. And the integration is the integral of dx over 1 plus x squared all squared. Now, the reason I've chosen this one is because, flicking through TikTok, I saw this integral advertised, as it were, and the presenter was about to do it in a rather sophisticated way. So I moved on. Now, you don't need any sophisticated techniques for this. All you need to do is let x equal tan theta, and then dx will equal sec squared theta d theta, and the integral will transform to the integral of 1 over 1 plus tan squared theta all squared times sec squared theta d theta, which is sec squared theta d theta over sec to the power 4 theta d theta, which comes down to cos squared theta d theta, which is 1 plus cos 2 theta over 2 d theta, which is theta over 2 plus sine 2 theta over 4, which, going back to the old variable, becomes 1/2 tan inverse x plus 1/4 2x over 1 plus x squared. Now, I'll explain how I've done that in the footnote, and that's equal to 1/2 bracket tan inverse x plus x over 1 plus x squared, plus the obligatory constant c. So if you look at the little triangle in the footnote, tan theta is x, so one side of the triangle is x, the other side is 1, and the hypotenuse will be square root 1 plus x squared. Now sine 2 theta is 2 sine theta cos theta, so that's 2 times x over square root 1 plus x squared times 1 over square root 1 plus x squared, which comes to 2x over 1 plus x squared. And that should explain that little step. Now, I've gone on further to say that integrals where the integrand is 1 plus x squared all cubed, 1 over 1 plus x squared to the power 4, and so on, can all be solved using the exact same substitution. Okay, so that brings us to the end, and thank you very much for listening.